Hey everybody, this is Michael Parent with Michael Parent Consulting Services. Today, what I wanted to do is start a conversation on measurement system analysis. Now, measurement system analysis, if you're doing this thing called continuous improvement, if you're doing this thing called process improvement or operational excellence, measurement system analysis is an incredibly important part of this improvement process, because what we'll do today is we'll talk about what a measurement system is, we'll talk about why it matters, and then we'll talk about kind of what's the goal of doing a measurement system analysis. So let's get started here. We'll talk first about a measurement system. A measurement system is really this: it's anything that you do to get a measurement from either a thing or a process. I've got some examples up here. The one that I think everyone knows, everyone is familiar with, is using a bathroom scale, right? So what's the process of getting a measurement for getting on the measurement scale? Well, if it's analog like this picture here, it's simply a matter of stepping on it, and then you've kind of like you're depressing some springs, and those springs are kind of moving this needle up. And then very importantly is you're actually taking a reading of this kind of analog needle, right? You're guesstimating that it's somewhere between maybe, let's be nice, 140 and 145 pounds, right? So, and then again, if you stepped off that scale and you took another measurement, again, those springs would depress, that needle would kind of bounce around, and then you would have to take another measurement. And that measurement might not be very precise because it's just a needle and you have to kind of reckon where that needle is. But that's an example of a measurement system, right? Is it's not just the instrument that you're using, it's also the process that you use to get that measurement out of it, right? So if you had a digital scale, we might expect that measurement system to be more reliable, more repeatable or reproducible between different people taking the reading, and it might be more precise as well, right? We have other examples of this type of instrumentation as well, right? Anytime you take pressure gauge on your car or on your tires to see whether or not you have enough air in them, or even if you're doing something more business related where you're trying to track, some cycle time or call times in a call center, right? You can track all of these things, but there are things in place, there are methods in place to get these numbers. Maybe they're automated in a database system, but still, they're worth understanding. The reason they're worth understanding is we make decisions based on these measurements, right? And if these measurements are incorrect, if they're telling us something that's not true in reality, but we're expecting them to be true in reality, or we're not scrutinizing that measurement system, we can be making the wrong decisions for our businesses and our lives, right? So if I'm asking the question, do I need to lose weight and go on a diet? It's very important that my scale tells me within, a couple pounds maybe, whether or not I actually need to go on that diet. If it's off by 20 pounds, that's severe, right? If it's off by 1 or 2 pounds, I'm not so worried about it, right? Do I need to add more air to my tires? And again, that's really relative. If my gauge is accurate within a psi or two, it's not that big of a deal. But if it's off by 10 or more, I'm in trouble. So this is really the reason why we care, is that in order to make good decisions, good business decisions, we have to have confidence that the measurements we're using are accurate and reliable. I'll give you a case of something that I've encountered in my career. I worked for a tire company for a time, and we had these tire balancers, kind of like PSI. That's one measurement to tell whether or not a tire is in good condition or not. We also had this thing that was balancing, which is pretty much, is your tire uniform? Or is it going to kind of bounce you around and make a lot of noise? And it's not a good tire if it's got uneven wear. And we do this thing called tire balancing, where it goes on this balancer, and then if it exceeds a certain amount, which means that it's kind of shaking around on this axle, then we say that tire's bad, you don't want to drive on it, and it has to be replaced. And of course, that replacement comes with some money, right? We're not giving away tires for free. Now, what we looked at is we looked at running the same tires on this dynamic balancer, is what we called it. And every time we did, what we actually found is that we got a different measurement. This measurement system varied in the same way, if you take the same reading of your tire a couple times, it might vary a little bit. But this was varying greatly. to the point where 15% of, we kind of said, we had a standard deviation statistical measure, but we had this thing. If I've got a tire that I know is 18 ounces in its dynamic balancing, right? It's not the reject. At 20 ounces, we're going to reject it because it's not balanced enough. But at 18 ounces, we can say that it's a good tire and put it back on the vehicle. But what we saw is that the measurement system was giving us an extra, kind of 2 ounces, and it was pushing a tire that we knew to be in specification out of specification. And this means that we were essentially costing up our customers and telling them that they needed to replace tires that they actually didn't. So obviously that's not a good customer experience. This is a real case, but it could also be the exact opposite, right? Is what if we were telling them that they had good tires when they really didn't, when they actually had bad tires, right? That's another very real possibility, that we're not able to protect our customers because we don't have a robust enough measurement system in place. So that's why it matters. It matters is, ultimately we're making business decisions. We're trying to deliver value to customers. And if we don't have these things in place, we're not capable of doing that. And worse, we don't even know that we're not capable of doing that. So this is kind of the paradigm that we use when we talk about measurement system analysis. We have the real process behavior, how much I actually weigh on a day-to-day, how much actual air pressures in my tires. But then I also have this variation of what am I measuring? Where is that needle on my analog bathroom scale? Where is my gauge shooting the air out on my tire? And what we see, what we make decisions on, is kind of this additive between the two of the real process behavior, the real product attribute, and the measurement system. And that's how we get this very large variation. And again, if we're actually supposed to be here, like right here, but instead I'm measuring over here because of the measurement variation, that's going to have dire consequences to our organization, to our ability to manage. So what's the goal of measurement system analysis, right? This is what it is. We're going to talk more about it over the next couple videos. But really, here's the thing. There's always going to be some variation in our measurement system. We're not going to aspire to say this will always be 100% right all of the time. Even when we get into, databases and grabbing things automatically, there's still small little variations there. Don't have to worry about that. We don't have to eliminate all variation from our measurement system. But what we want to do is we want to ensure that the differences are very small relative to the actual measurements. Like I said, if I'm trying to make a decision on whether or not to go on a diet and my bathroom scale is off by half a pound, that's not a big deal. If it's off by 50 pounds, that's a huge deal, right? Same with my tires. If it's off by a PSI or two, it's not a big deal. But if it's off by 10, I'm making a really big decision on whether or not to fill that tire based on bad information. So that's the importance here, is that we want to ensure that the differences that we have are small, and that there's also not, a systematic bias, not a social systematic bias, but I want to make sure that I'm not constantly over-reporting or under-reporting my numbers, right? I want there to be some variation, but it to be kind of random and still kind of focused around the true reality of my process or product. So this is what we want to do for the goal, is we want to validate that the process, that the measurement system is actually capable of doing what we want it to do. And then most importantly, if it's not, we can have a project aimed specifically at getting us better numbers so that we can have better confidence in our processes and our products and making the decisions that come off of and that are reflected from those measurements. So I'm going to have more videos on measurement system analysis and measurement systems, but for now, this is a good primer and introduction into what it is.